All right, let's get started. Thank you very much for coming. For past 10 years, roughly, because in 2007 I started doing first experiments with mocking, something bothered me. The thing that bothered me was that Mockito, like being a really good framework with really clean API and really driving nice, clean tests, for certain specific use cases, the old mocking frameworks that Mockito used to compete with those other mocking frameworks, you could have slightly better experience when it comes to debugging, right? And that bothered me for like nearly 10 years. And now, finally, with Mockito version 2 that was released in October last year, finally, I was able to address that, and with the team, we started to making progress on those use cases. And this presentation is focused around that. So although Mockito has like a couple of very nice features, I want to focus exclusively on the debuggability experience and also like clarity of tests, like how clean your tests can be with Mockito. So I'm Szczepan Faber. I originally come from Poland, but now I live in US. And you might know me from my work with Mockito or Gradle. And right now I'm a tech lead at LinkedIn Development Tools team, and my team is pretty awesome and is hiring, so think about it. In 2008, there was no way to run clean tests, so Mockito 1.0 was created. I published 1.0 in January, I believe. This is where I used to work on Mockito. This is the tube station somewhere in London. I used to work on Mockito on my commute. Some random tech people would sit by my side and we would do some spontaneous pair programming. That was how it was done. And in 2017, nowadays, Mockito has roughly 2 million users, and it could be one of the top 3 Java libraries. And I have real data for you to prove it. So with the 2 million users, that's the rough estimate. According to some official statistics, there are like 10 million Java engineers. So assuming that half of them writes unit tests, it's kind of sad, but probably true. And let's say that that half actually uses Mockito for doing mocks. This gives me this cautious estimate that let's say we have 2 million users, which is pretty good. Also, it feels that Mockito is pretty good when it comes to Java popularity. Every now and then there is research done, and most popular repositories on GitHub are indexed and inspected for their dependencies. This is the research from 2016. About 4,000 most popular GitHub repositories were parsed and identified what dependencies they use. And Mockito L and Mockito Core were frequently appearing. Mockito Core and Mockito All is the same thing. I hope you no longer use Mockito All. That was the legacy artifact that contained all the dependencies. And in 2008, back in the old times, such artifact was useful because at the time, people not necessarily used dependency management as we use it today. Like many times, team checked in their binary dependencies in the source code, and like dependencies that contained other dependencies like Mockito All was useful. But given Mockito Core and Mockito All is the same thing, I was able, like when I collect and add together the results for those two, we are on number 3. Like better than Guava, yeah! Guava is awesome, so. In 2016, this guy helped me out. This is David Allen. Actually, I should use my clicker. So David Allen, he wrote this book, Getting Things Done. It helped me with my life and with work, like getting things done and really engaging with the open source community and engaging with the work that needed to be done with Mockito. Community and some of the other guys on my team, on the Mockito Core team, they did tremendous work. Awesome. So thanks to David Allen as well. Mockito 2, the way I like to think about Mockito 2 is that it really it addresses this gap that I saw with Mockito and like adds more debuggability and more clarity to your tests. And I'll demonstrate that in a second. Before that happens, I want to leave you with one thought, that writing clean tests and writing like, poor tests, it takes exactly the same effort, right? It's just different level of discipline. So just add that discipline, think about the quality of your tests, and you really are not going to spend more time on it. And in the long run, it will actually be faster. So I'm all for clean tests. And now it's time for live coding. Let's get started. I'm going to go to IntelliJ, and I hope the font is OK, so let me know if it isn't. Actually, before I do that, the sample project that I created for testing, smart dictionary test, I actually recorded like a short video, which I'm going to run now so that you can see that. I'm going to turn that off. I thought that I can like test drive the entire project for you here, but then when I recorded it, when I pre-recorded that, it was like 8 minutes, which is like too long. It would be like almost 1/3 of the time I have for this session. So I just show you the beginnings. So I was able to like test drive some basic functionality like a class, and then we will be building some use cases on top of that. What I want to highlight here is that the way I've been doing that is my favorite style of development, which is test-driven development. And what is interesting and sort of counterintuitive in this style of developing is that I'm actually typing code that does not exist yet. Like if you see there, like the smart dictionary class does not exist yet, and various methods don't exist yet, I will generate those methods from the code. So I used that method to actually design my code before I actually code it. And it's very counterintuitive because as engineers, we are more used to like using classes that already exist, right? And here it's like, it's kind of backwards. The cool benefit of that, of developing code like that, is that I can not only like design my interfaces and my code before I actually write that code, I can also save time on generating those classes and those method stubs right there from the IDE. So try that at home. You know, try to write this more test-driven development, use the classes that don't exist yet, and generate them from the code. I will now shift to real coding. So thank you, Szczepan, for this demo here. OK, so I have this class here. I want to show you, let's hide actually. Is it like that? There you go. I'm going to collapse all the methods to explain you the behavior we're testing. So I have a smart dictionary object. This is the test for that. And I have 3 methods that cover 3 basic functionalities that smart dictionary provides. So it needs to look up words. It needs to keep the history of the lookups. And it will ignore, if there are any history failures, it will ignore those failures. Instead of showing you the tests, I'll show you the code because I think it's simpler. And it's pretty basic. I want to use that sort of a hello world example to demonstrate you some of the things that I'm super excited about in Mockito v2. So we are asking Wiki for the description. We are storing the lookup attempt in the history. We ignore the failure, and we return the description. Let's get back to the tests. I will run those tests now. They all pass. The problem I want to demonstrate is the debuggability experience when you mess something up. Either you make a mistake in the test code, or the production code that you're testing is not behaving correctly, and you are in the middle of like developing your tests, and you have this problem that you don't understand why your tests are failing. So I will sort of emulate that scenario. That scenario I can emulate by making a typo in the parameter that we use for doing things. So for example, in my test that verifies that we are keeping the lookup attempts in history, I make a typo in the argument, and I will run this test now. So this will actually provide us very nice error. Mockito tells us precisely what happened, that you are verifying the method with the argument Mockito. What we are getting, the argument that is, I hope you can see that. It's a different argument. If you know how certain tricks, how to be very productive with Mockito, you should also know that for all the exception messages, all the exceptions coming from Mockito that deal with comparing things, we try to use the exception types that IntelliJ understands. That's why you can do things like that. You can click to see the difference and actually see the difference in the arguments here in that nice IntelliJ window. So this is pretty good for verification. Mockito story, when you are messing up something with the arguments and stuff, it's going to give you a very nice debuggability experience. You should be able to figure out the problem fast. However, I want to show you that for stubbing, it's not the case. For stubbing, the experience is not nice. I will run that test now. What happens here is that the framework fails on the assertion. So here, if I click on the stack trace, it fails here. And it fails sort of late in the game. Like I made a mistake with stubbing. So I would expect that the smart framework will tell you, hey, you have some problem with stubbing, because you're stubbing with this argument, but in the real code, when you're executing test, a different argument is used. Mockito is not that smart, I guess. And this was the use case that traditional mocking frameworks of the old times, EasyMock or JMock, were actually a little bit better, because those frameworks by default were strict, which means that if certain interactions happened with the mock objects and you haven't accounted for those interactions, you forgot to specify those interactions, the code will fail early and will give you a nicer debuggability experience. You would see, oh, I'm messing up with the argument. And Mockito does not offer that. Now, there is a good reason Mockito does not offer that. So in the next step, I want to emulate strict mocks with Mockito. Mockito mocks are not strict. They are very lenient. Mockito does not care if the methods you're stubbed were used or were not used. And, but what if you want to have strict mocks in Mockito? By the way, any one of you who is familiar with strict mocks would like to have strict mocking support in Mockito? Anyone? Okay, cool. I see some hands. Nice. So I'll show you what happens if we have strict mocks in Mockito. In Mockito, there is no API for strict mocks. There's no, there's no such feature, but I can create that feature relatively cheaply. So let me do that. So here, instead of mock, I'm going to have a method strict mock, and same for that. Let me create that method. It's going to return, it's going to be parameterized, it's going to return type, and here it's going to be like that, type to mock, and here I will return mock, type to mock, and I will configure the default. I'll change the answer. Is this how I do it? Hang on. There you go. I can pass a default answer that the mock gives when any method is invoked on the mock. By default, the answer with Mockito is, return some dummy values or just ignore it. I will change that default value. And instead of returning something, I will do throw new Mockito exception, unexpected interaction or invocation. Let's say we have something like that. Now I will run this test. And actually one more thing. Thank you. I'm going to use lambda. It's going to be nicer. Oh, thank you very much. I wanted to do Mockito exception, right? The reason I'm doing Mockito exception because Mockito exception will give me some nice stack trace filtering. But runtime exception would do too. Thank you. Nice catch. I will run that test again. Previously, it failed with assertion, which is kind of late. Does not give me good debuggability. Now when I run it, actually, there's one more thing I need to do to make it working properly. And I will not completely explain it, so you have to trust me. There are two ways of stubbing in Mockito. One is this traditional way where you say, given that interaction, I will return some value. There's also a way of doing that when we start with will return mocking framework given wiki find description. Those two lines are synonymous. It's the same thing. Will return is used, or will throw, rather, this style of syntax is used for stubbing void methods. The reason is there are certain syntax limitation. I can't have a void method here in a bracket. So sometimes, as you use Mockito, you'll have to use this slightly different syntax of stubbing where you inverse the order. First you specify what you return or what you throw, and then you specify which method. And actually, I think this should be like that. So it's the same thing. If I have time, I can explain why in this particular context I needed to do it. Suffice to say for now that I need to do it in order to have the strict mock, this dummy implementation of strict mock working. Okay, I'm going to run this test now. And what's happening, it's telling me now that there's unexpected invocation, which is better. Because previously it was failing with assertion, and now it's failing with unexpected invocation. So it's failing closer to the problem that we have, which is nice. And if I grow that solution and add some more capability to the strict mock, I could have made that exception even nicer. That would tell me, hey, this is how you have, this is how the method is invoked, but it was stubbed with a different argument, so I could make it better. This is the strict mock in action, and if you can see, it gives me a little bit better failure, closer to the real problem. However, when I come back to the test, and let's say I fix my typo. Where's my typo? My typo is here. I'm going to run this test. It still fails because now it says that there is a lookup attempt unexpected. Because I'm using strict mocks, I have to specify all the things that are happening with my mocks. So I'm going to have to do something like that. We'll do nothing given history, lookup attempt, Mockito. I will run it now, and it passes. I'm going to run other tests. Note that the only difference I did, I started to use strict mocks. I'm going to run all the tests. Now what's happening is only the first method passes. The other two methods are failing, even though when I look at the code, like the code is correct. There's no bug there in the code. So why the tests are failing? So the tests are failing because I'm using strict mocks. And strict mocks require me to somewhat accommodate all the invocations, all the interactions. I have to specify them. And this is against the philosophy of Mockito. Mockito drives clarity of tests by making it possible and actually advocating that to separate the behavior you're testing to separate methods, right? I do not want to specify all the things that are happening with my mocks in every test method, because that defeats the purpose of a nicely isolated, small test methods that focus on individual behavior. And even in this first test, I have that problem. Like in this test, I want to focus on one single behavior of interacting with the wiki. But now, because I'm using strict mock for history, I have to accommodate that there is a history lookup attempt. So I hope that with this example, I can show you that there is a downside of using strict mocks. And that was one of the reasons I created Mockito. I really didn't like the old style of doing like strict mocks with like easy mock and JMock. For the record, there are ways to change the easy mocks and JMocks and all those to be also lenient, but that was the default behavior. The default behavior of EasyMock or JMock or many other mocking frameworks is strict. And what I have observed in large code bases where engineers were using those frameworks is that the typical way of solving problems when the code base grows is to basically add more interactions to tests. And each test method has so many interactions with so many mocks. I did not want Mockito to go down that path. I wanted Mockito to drive like more focused, specific test methods. That's why Mockito is lenient and will stay lenient. But I want to solve that puzzle. I want to make Mockito easy to debug. I want to make that use case better. And finally, with the Mockito v2, we got it. So I will stop using the strict mock. So I'm going to change that to basically to be mock. I kill that method. Oops, I'm going to use mock here as well.
How far is that? You are actually like skipping and ignoring all the history functionality that's behind the scenes.
So let me finish off, and I'm happy to take questions. Is that okay? All right, thank you. So let me run the test again. This should pass. No, hang on, this one doesn't pass. Why not? Do I still have typo? Oh, I removed the right thing. Okay, thank you. We'll return mocking framework given what? Given wiki, find description. Okay. I'm going to run all my tests again. the typo that I used before could happen, or the problem with stabbing could be here, but also if you have some complicated logic that you're testing, you might have problems with arguments inside of the code. So I will use a different variant of this problem here. So word plus equals question mark. Let's say we have something, this is like an example of argument problem. I'm gonna come back. I'm gonna run this test. So far it's not using Mockito v2 features. We have an assertion failure, and that failure is far away from the problem, and I can't easily debug, can't quickly debug. So in order to show you the Mockito v2 features, I will start using the JUnit rule first. JUnit rule is something that was available in prior version of Mockito, so there's nothing new, but we have added some nice new default behavior to JUnit rule. And I'm running out of time, unfortunately. Come on. Faster. Okay, so this is going to be a mock. This is going to be a mock. I don't need the, because I will use the JUnit rule in a second, I can use some nice Mockito annotations. Like that. And I want to use, oops, public rule, Mockito rule, Mockito rule equals Mockito JUnit rule. Okay, we've got this. Let's clean that up a little bit. So I have rule. I'm going to run all the tests again. There will be failures because I have this artificial sort of bug here. And coming back to my original test, this is the test that I'm focusing on. So when you are using JUnit rule, the first thing that we've added in Mockito v2 is a warning on the console showing you that there's something wrong with your arguments. And if you read it, and if you can't quite parse and understand it, you can go to Mockito hint class, view the Java doc, and it has a comprehensive documentation what it really means. Suffice to say that this warning is intended to help you figure out and kind of debug when you have those like slight argument issues. But that's like, warning is not good enough, right? Like, we don't look at the console that often. It's kind of hard to figure out. So how can it be even better? So we added a new optional strict stub feature. So I can make my rule to operate in this strict stubs mode. This is not strict mocking. This is strict stubbing, which is the best of both worlds. It will give you the debuggability you need and the cleaner tests without all the weight of strict mocks. What's happening now when I run this test, I have a failure that is different. I don't have assertion failure. It tells me that there's a potential stubbing problem, strict stubbing argument mismatch, and you have a nice clickable exception message where you can click here, and you can find out that the expected invocation of that method uses a different argument. This is where you have stubbed that. So this is like a nice thing that is added by opt-in feature with strict stubs. You can also get that behavior using Mockito JUnit runner. There's also an API to get that behavior without using JUnit support. So you can do it even without JUnit rule. I won't have time to show it, but it's all very well documented. I want to show you more features of strict stub because the fact that it conveniently tells you what's wrong with your test when you have problems with stubbing, it has also two other important features. One is that your tests will be more dry. Don't repeat yourself. There are occasionally use cases where you want to verify that there are no other interactions with your mock. For the API for that in Mockito is the verify no more interactions method. And I personally use it rarely, but there are cases where you really need to be specific. You really don't want to have any other interactions. And in this artificial use case, when I run it, actually I'm going to go back to the implementation. I'm going to fix my bug. I'm going to run my test. Actually, no. And I remove the strict stub. So this is the default behavior you get if you don't opt in for strict stubs. What's happening is that I've declared this stubbing for the wiki object. I verify that there are no more interactions with the wiki object, but Mockito fails. But hey, like, what do you mean no more interactions? There is an interaction. There is an interaction here. Find description. So Mockito forces me to do this: verify wiki, find description, Mockito. And this is not great. This is not smart, because I'm repeating myself. I'm repeating exactly the same interaction. I'm repeating this here in 2 places. So it was also bothering me that for certain rare use cases where you really need to be specific and you want to verify that nothing else happened, using verify no more interactions, you have to duplicate your stabbings. So basically you duplicate code, and like that's not, the clean code is not duplicated code. Now, if you're using strict stubs, you don't have that problem, because strict stubs validate that the stub was actually used, which means we guarantee you, like, you don't need to use verify no more interactions with strict stubbing, because we guarantee that stubs are used. And I don't need to use that. So I'm more dry. Don't repeat yourself. See, this is working. Final feature of strict stubs is the validation of unnecessary stubs, which are essentially dead code. I will do, let's say I have something else here. Foo bar. Let's say I have some copy-pasted code or something, some legacy or whatnot, and in the normal behavior of Mockito, so I'm going to remove the strict stubs. I'm going to run this test. It's failing because of the verify. I'm going to remove the verify no more interaction. So I have the code that I had before, with only difference is that I've added this extra additional stubbing that is not used by anything, but let's say I forgot to remove it. Oh, don't go. I'm going to run it, and Mockito says, all good. There is actually, with Mockito, 2 default behavior or rule is the warning. So you get a warning on the console, but again, warnings is not something that gives very good signal. It's very easy to overlook. So it's not great. If you use strict stubs, and run this test, it'll actually fail saying that, sorry, there's an unnecessary stubbing, please remove it. So you can get rid of that code, like some of the stubbings that you don't know. And you would be surprised if you run this Mockito with strictness, with strict stubbing on your code base, in how many places of your code you have unnecessary stubbings. You're like, you wouldn't know, but there exist. And that's the feature number 3 of strict stubs, which is avoidance of unnecessary stubs, the stuff that you also get with JUnit runner. But since I'm running out of time, I'm going to jump to presentation quickly to finish off. And those 3 key features. And with that presentation, I wanted to give you a little bit understanding about strict mocks. Is that strict mocks, they add value, but there are certain things that they will also, that are not nice in certain respects. By the way, this is how I looked when I was young. But I started writing so many tests, and now I'm no longer that pretty. So with Mockito v2, for cleaner tests, what you have is like easier debugging with those stubbing issues, dry, so you don't repeat yourself when you don't have to verify stubs, and you have dead test code detection. Unnecessary stubs are detected. Other features of v2 that I didn't focus today, we have a built-in Android support. We replaced cglib with fantastic byte body library. We have support for mocking finals, and hopefully at some point, like getting even better, or maybe even mock statics. Who knows? We'll see. We have various rather smaller API tweaks that makes Mockito more intuitive. We have new API for like extending Mockito and like getting into the details of Mockito, which is nice. Java 8 is supported much better, like lambdas and things like that. There's also a really cool project on GitHub, Mockito release tools, to nudge and shift the Java community more closer to the model where every pull request ships a new version to Maven Central. Yeah. With that, I maybe have time for like one question and finish at 4:01. You had a question?
Yeah, I had a question like why you are so against strict rules?
Oh, so why? I wanted to demonstrate that strict mocks in general like produce low-quality test code base with over-specified tests that specify too many interactions, often interactions I don't care in my test code. So that's my belief. Of course, we can argue. You can have your own presentation about strict mocks and how cool they are. It will be, thank you. So strict stub, good default. Yeah, it is a good default. One thing I forgot to mention is that you can easily opt out from that default per test, so that, for edge cases, you might want to opt out. You wait for Mockito 3. In Mockito 3, we plan to like turn it on by default, so yeah, let's do Mockito v3, let's upgrade our code base, and then, oh God, like so many tests are failing, what's going on now? Let's stick to Mockito 2. So I think I gotta finish, but thank you very much for coming, and like catch me at the corridor somewhere and we can chat about Mockito or other things. Thank you.